today the very first heading as basic trigonometric ratios. Basic trigonometric ratios, right? And now here we consider first a right angle triangle this way. Suppose this right angle triangle, here we have the 90-degree angle, and I take this triangle as ABC, right? When I consider this angle as theta, this angle as theta, the side, this BC, which is opposite to this angle theta, is called as people opposite side, and with the angle the side AB available is called as people adjacent side. Adjacent side. You know, in the right angle triangle, the side opposite to the 90-degree angle, that is this, is called as people hypotenuse. Hypotenuse. Now, we first define three trigonometric ratios that you have already defined in your O levels. First one is people the sine ratio of the angle theta. Sine ratio of the angle theta. The way of writing that is this people. The full word is SINE, sine theta. Right? SINE. But when we write this sine, we write only SIN this way. The sine ratio of the angle theta we define people the opposite side length divided by the length of the hypotenuse. Okay, so it is BC divided by AC. Then this is BC divided by AC is the sine theta, sine ratio of the angle theta. Secondly, we define another trigonometric ratios. People, this angle theta, it's cosine, cosine theta, cosine theta. Second ratio of the angle theta is cosine theta, cosine theta. The cosine theta, people, we usually write this cosine theta as cos theta. We drop this INE part, cos theta. This cos theta, people, we define the adjacent side AB divided by the hypotenuse, right? Adjacent side AB divided by this hypotenuse AC. This is how we define the cosine theta or cos theta of the angle theta, right? Third one, people, this angle theta, tangent theta. Tangent theta. This tangent theta we write as tan theta. This is how we write. The full word is tangent theta. We write it as tan theta. Tangent theta we define people the length of the opposite side divided by the adjacent side, right? BC divided by AB. So this way you have done this in your O levels, right? BC divided by AB. This way we define the three basic trigonometric ratios. Understood, people, right? Okay. In addition to this three basic trigonometric ratios, people, we define another three more. We define another three more. Those three you haven't done in your O levels. They are new trigonometric ratios for you. We learned that first time in A levels. Those three, if I mention, people, you can consider this way: 1 upon sine theta. We take the reciprocal of sine theta. this 1 upon sine theta, people, we define as cosecant theta. Cosecant theta. Cosecant theta. But when we write this cosecant theta, people, we write it as cosec theta. Cosec theta. Then 1 upon sine theta is cosec theta. That is a new trigonometric ratio. Cosecant theta. Cosecant theta is the ratio. It is 1 upon sine theta. That means reciprocal of sine theta. Reciprocal of sine theta. That means 1 upon sine theta. This way we can write it. Okay. So this is the fourth one. People, another one more we have. That is the reciprocal of cos theta. This way. 1 upon cosine theta. 1 upon cosine theta. People, this is known as secant theta. Secant theta. Secant theta. Right? But this secant theta we write as sec theta. Right? And this is cos theta. 1 upon cos theta, therefore, people, we write as sec theta. And another one more we have. The reciprocal of tangent theta. That means tan theta. Reciprocal of tangent theta. 1 upon tangent theta. This is, people, defined to be cotangent theta. Cotangent theta. This is cot theta. Right? Then this is 1 upon tan theta. This way, people, we define another 3 more trigonometric ratios. Understood? Okay? Right. Now, when you very carefully consider here, people, another 2 more relations we can see here. We will come to that rest 2 results after taking a brief note of this thing. Okay? Right, people, then we'll write a brief note. Right. Write down like this, the heading as basic trigonometric ratios. And then write down like this, consider a right-angled triangle ABC, right-angled triangle ABC with BAC angle theta. With BAC angle theta. Right. Then draw this diagram, people. Andil namai sadahanna. Draw the triangle. Okay, then write down this angle theta. Opposite to this angle theta, the side, this is known as the opposite side. With the angle theta, there are 2 sides, but the side which is opposite to the right angle is hypotenuse. The other one is called as the adjacent side of the angle theta. Okay, then mark this. This is called as hypotenuse. Opposite side, this is the adjacent side. Okay, right. And now write down another sentence. Write down 3 basic trigonometric ratios are defined as follows. Are defined as follows. Right, people, now write down one by one. Number 1 is this. Number 2 is this. Number 3 is this. Sine theta. Full word is people SINE. 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 But when we write it, we write only SIN. Then according to this pronunciation, we must pronounce that as sin people, but we don't define that as pronounce that as sin. We write having this E in our mind as sine. Right. Write down sine theta this way. It is opposite side divided by the hypotenuse. Number 2, cosine theta. Full word is cosine theta. It's cos theta. Adjacent side divided by the hypotenuse. Tangent theta. Full word is this people, though we write that as tan theta. It is adjacent side divided by the opposite side divided by the adjacent side. The tan theta, right? BC divided by AB. Okay. Right. We have to stop here, right? Write down. After reaching here, write down people. Another 3 more. Another 3 more trigonometric ratios are defined as follows. Are defined as follows. Are defined as follows. Then people write on this first one. 1 upon sine theta. That sine theta is at the denominator. 1 upon sine theta. It is cosecant theta. Cosecant theta. That cosecant theta people we write as cosec theta. ළමයි මේ cosecant theta අපි ලියන්නේ cosec theta කියලා. අපි මෙන්න මේ ANT තුනලා ලියන්නේ නැහැ. Cosec theta. This is number 4. And number 5 is this. 1 upon cosine theta. 1 upon cosine theta. It is people secant theta. Secant theta, that secant theta we write as sec theta. Number 6, next one. Number 6, next one. 1 upon tangent theta. 1 upon tangent theta. It is defined as people cotangent theta. Cotangent theta. That cotangent theta we write people as cot theta. Cot theta. This way. Right. Throughout your A-levels people, whenever you speak about trigonometry, always we have to work out with the 6 trigonometric ratios. Sine theta, cos theta, tan theta, cosec theta, sec theta, and cot theta. Right. People, another 2 more results as I told you earlier, we can obtain now like this. Now, this sine theta ratio, I'm going to divide by this cos theta ratio. Okay. Sine theta ratio, when I divide by cos theta ratio, see what happens. Right. We can write putting a star mark. People we write sine theta, we divide by cos theta. Right. Sine theta is this BC upon AC. We have no cos theta AB upon AC. People, this divide by this, I can write this way too. Sine theta divided by cos theta. It is BC divided by AC whole thing divided by. Now this line means people division, right? This line means it says this is divided by this. So then for this line only I put here the division sign. So therefore this one you can write as AB by AC. Okay, right. Now I can write this BC divided by AC. This division sign I can write as people multiplication sign, and thereafter we can take what the reciprocal of this fraction. Reciprocal means people we interchange numerator and denominator, right? This multiplied by AC divided by AB. You can see this AC and this AC you can cut down. Then what you get is BC divided by AB. But people, this BC divided by AB is nothing but what? BC divided by AB is equal tan theta. So therefore, this one I can write as tan theta. What do you understand by this? When we divide sine theta value by the cos theta value, the answer is people tan theta. Conversely, tan theta you can write as sine theta by cos theta. Understood, right? Yeah. Then we can write sine theta by cos theta. Sine theta by cos theta is tan theta. Sine theta by cos theta is tan theta, right? Or else we can write tan theta is equal to sine theta divided by cos theta. Sine theta divided by cos theta tan theta. Conversely, tan theta equals sine theta by cos theta. Understood? Okay. Right, people. Now we take next this cot theta, people. We can obtain cot theta is 1 upon tan theta. Now this cot theta we can write people this way. Right here, cot theta is equal to 1 divided by tan theta. No, right here. Look at this. Cot theta is 1 divided by tan theta. Right. Now this 1 divided by tan theta I can write like this. 1. This line means divided. Tan theta. Right. Now we can write 1 divided by tan theta. People, tan theta is this, no? Here, tan theta is sine theta divided by cos theta. Right. I can put that there. Sine theta divided by cos theta. Now I can write in the next step like this: 1 multiplied by this division sign we write as a multiplication. Thereafter that fraction we take its reciprocal. That means we interchange numerator and denominator like this. Cos theta divided by sine theta. Right. You know, when we multiply something by 1, the value does not change, people. ඕනෑම එකක් ඕනෑම සංඛ්‍යාවක් එකකින් වැඩි කරාට සංඛ්‍යාව වෙනස් වෙන්නේ නැහැ ළම. So therefore here cos theta divided by sin theta when you multiply by 1, the same thing we get. Then we can write cot theta equals cos theta divided by sin theta. Then cot theta you can write as cos theta divided by sin theta, right? Or cos theta divided by sin theta we can write as people cot theta. Understand? So therefore in this case tan theta you can write sin by cos. Cot theta when you write, people, we have to take the other way around, cos by sin. So then for both tan theta and cot theta, cos and sine are involving. But the order you have to very carefully remember. People, you can very easily remember that when you write cot theta, that starts with C, no? Then its right hand side above the line, the ratio should be starting with C. It is cos. So therefore, cot theta you can remember as people cos theta by sine theta. Understand? Right? Cot theta ලියනකොට ළමයි මතක තියාගන්න cot theta පටන් ගන්න 100 අකුරෙන්නේ. එවනම් අර පැත්තෙත් ඉතින් උඩ 100 අකුරෙන් පටන් ගන්න ඕන එක මතක තියාගන්න. 100 අකුරෙන් පටන් ගන්නේ cos. Cos by sine is cot. Then you can very easily remember tan. It is other way around, no? Sine by cos. Understood, right? So these are the basic things that we should understand. Cot theta is cos theta by sine theta, or cos theta by sine theta is equal to cot theta. Both directions we can consider that, huh? Right? Okay. Now we are going to obtain people the basic trigonometric formulae. Basic trigonometric formulae, right? And then we'll write people next subheading like this: basic trigonometric formulae. Right. Basic trigonometric formulae. Right, now people, I am going to use the same triangle again, right? So these things of course I am going to erase, huh? And for this angle theta I need sine theta. We know it is opposite side divided by the hypotenuse, no? Cos theta, it is the adjacent side divided by the hypotenuse, no? Right? And the tan theta we know it is opposite side BC divided by the adjacent side AB. That we know already. Right? Now people, the very first trigonometric formula I am going to obtain by using the Pythagoras theorem or Pythagorean theorem applied to this triangle ABC. So the triangle, right angle triangle, you know, the Pythagoras theorem is valid. Pythagoras theorem is valid only for right angle triangles, people. Right angle triangles. People, what is this Pythagoras theorem? It says perfect square root of this hypotenuse is equal to the sum of the squares of the other two sides. Then we can start to write. First, write people basic trigonometric formulae, and it's better to draw people this diagram again, the same diagram, but we'll draw this one now. Right? Draw this diagram and write down like this: sine theta, cos theta, and tan theta. This way. Now I am going to apply Pythagorean theorem to the triangle ABC. Right? Right. Now I'm drawing this and write. And now write by Pythagorean theorem. By Pythagorean theorem, you can write what, people? This AB perfect squared plus BC perfect squared is equal to BC perfect squared. Right? Now people, both sides of this equation I am going to divide by AC squared. Both sides of an equation we can divide by any value, people. The equation will not be changing. It doesn't change, right? Yeah. Now, once I divide this both sides by AC square, this is what we get. AB square divided by AC square plus BC square divided by AC square equals AC square divided by AC square. This way we get. On the right hand side, people, we can cut down like this. AC square, then AC square, we can cut down. In the left hand side, here we have at the numerator BC square divided by AC square. This square, people, we can write, putting this BC and AC inside the bracket, and this square we can put out of that bracket. And now I can write this way, BC divided by AC perfect square, this way. Then you know, according to the laws of indices, when we simplify, both this BC and AC should be raised to the power 2 to give BC square divided by AC square. And here also we can write the same way, AB by AC perfect square, this way. On the right hand side, people, now we have 1. But you know, here this AB divided by AC, AB divided by AC, we have within bracket. That is nothing but cos theta. Therefore, this is cos theta and to the power 2. Cos theta to the power 2. Plus this BC upon AC, here we have, look at this, BC upon AC. BC upon AC, people, sine theta. So therefore, the part within bracket is sine theta perfect square equals 1. Okay. Now, people, you know, when we have something like this, within bracket we have x squared, right? This is written like this, no? X squared. Okay. Now here also, when you square this, you might think that to write cos theta perfect square, to write like this, cos theta squared like this. No, people, that is not the way of writing this. Cos theta perfect squared, we write not this way, people. This is not the way of writing that, cos theta perfect square. It is written as, people, cos squared theta, this way. Cos squared theta, this way we write. Before we read this theta, we read this square. Then what is meant by this cos squared theta? It is cos theta perfect squared. In other words, cos squared theta means, people, cos theta multiplied by cos theta. Understand? Right. And here also, this one we write, people, sine theta perfect squared as sine squared theta. Sine squared theta mean what, people? Sine theta perfect squared, that is sine theta multiplied by sine theta. And this is equal to 1. Understand? So now you know cos square theta plus sine square theta 1. Though we interchange the order of this sum, the sum 1 change, no, people, 2 plus 3, and interchange in the order 3 plus 2. Being equal. Then I can write this one. This is correct, but we usually keep this sine square at the beginning. Sine square theta plus cos square theta is 1. People, this is the very first formula in the trigonometry we learned. It is sine square theta plus cos square theta is 1, is equal to 1. Right. Okay, people, now obtain up to there. Sine square theta mean sine theta multiplied by sine theta. Then only we get perfect square of sine theta. Right. Sine square theta plus cos square theta is 1. Right. Now up to there, take down the note. Right? Okay, people. Am I heard? Right. We obtain people by this another two sub formulae. Right? People to take this, we use this right angle triangle. Another two more we take for them. That number one formula is very much enough. Right? Let's see how to take the rest formulae. Right? From this sine square theta plus cos square theta, because we take another two more trigonometric results. Right? This way we can obtain them. First thing is this. Right? Simple A we take. You know this sine square theta plus cos square theta is equal to 1. No? I take this cos square theta to right hand side. Once we take this cos square theta to right hand side, people, that will be minus cos square theta. You know that, no? When we bring a term from one side to other side of the equal sign, the sign of the term will change. Right? So then I can write sine square theta, take this right hand side, 1 minus cos square theta. Right now, because this 1 I can write as, okay, 1 I can write as 1 squared, because 1 squared is 1. Cos square theta mean, people, cos theta perfect squared, we know that. Then here you have difference of 2 squares. Then you can factorize that. And then what are the factors? Then we can write sine square theta as how, people? 1 minus cos squared theta, and also you can factorize here. This is like a squared minus b squared. A squared minus b squared means what, people? A minus b into a plus b. Then this is 1 minus cos theta into 1 plus cos theta. So therefore, this is the first sub formulae. Sine square theta we can write as 1 minus cos square theta. That 1 minus cos square theta we can write by factorizing 1 minus cos theta into 1 plus cos theta. Then this way we get first sub formula. Even now, similarly, are we subjected sine square theta? No. Now we subject cos square theta, taking the sine square theta to right hand side. Also we can write this way, sine square theta plus cos square theta is 1. Now we subject this cos square theta, taking the sine square theta to right hand side, 1 minus sine square theta. This 1 I can write as 1 squared minus sine square theta I can write as equal sine theta perfect squared. Right now? Now the next step we can write cos square theta is equal to 1 minus sine square theta. And here you can factorize this using difference of two squares. 1 minus sine theta into 1 plus sine theta, no? Right. 1 minus sine theta into 1 plus sine theta. This way, people, we can take down two sub formulae by number 1 using number 1. They are very important. Right. Take that two, people. Right. Now we move to second trigonometric formula. Second trigonometric formula. Right? Yeah. We obtain that as follows, people. I think you have obtained this all, no? Remember these people, right? I straight away use them in working out questions. මේවා ළමයි අපි කෙලින්ම පාවිච්චි කරනවා ගාන කරනකොට. We must practice this writing this again and again, right? Okay, no need to buy heart, people. No need to buy heart. By doing, keep doing this again and again and practice. Then no need to pay more attention or effort to remember this all, right? මේවා ළමයි නැවත කරන්න. කටපාඩම් කරන්න එපා. Don't buy heart. කටපාඩම් කරන්න එපා. ආය කරන්න. Taking a piece of paper, people write always. Think and write, think and write, think and write. That is the only way to keep this in your deep memory for long time period, right? Otherwise, if you by heart these people, by heart means it is having the forgetful nature. කටපාඩම් කරනවා කියන එක ළමයි ඉක්මනින් අමතක වෙන්න පුළුවන්. ඒ නිසා කටපාඩම් කරන්න යන්න එපා. maths කවදාවත් කටපාඩම් කරන්න යන්න එපා. Don't by heart people maths any day. Maths must be done, people, always with your practice. To your backbone, we have to take this structure of this math, right? මොඳු නාරටිම ගන්න ළමයි මේක. ඒක තමයි maths දේශි වෙන්නේ. නැතුව කටපාඩම් කරන්න යන්න එපා. ආය ලියන්න මේක. නැවත ලියලා මතක තියාගන්න. මේ වගේ ගොඩක් දේවල් එනවා අපට මේ lesson එකේ මතක තියාගන්න. We will take people another 28 more formulae in this lesson. In our first group students, people they have now passed these barriers. Now we have been doing that trigonometry lesson for the first group students more than I think 2.5 months. Now we have reached to the end. Tomorrow morning we have the class, and we supposed to discuss the 2020 past paper sum, the last year past paper sum also we supposed to discuss. Up to that level, of course, during these 2.5 months, of course, I developed their what knowledge, and most of the students, of course, they happy with the lesson. Some of the students, of course, message me telling that we tried this past paper sums here and there we can do. Then I told, don't be hurry, we have more time to do. Till I do another 5-6 questions, wait. They are okay at the moment, people. I am sure after another 2 months, you also actually will be at that level if you work properly from the very beginning, right? From the very beginning, right? Okay, people, now second one. To get the second one, what we do is this. The first formula, sine square theta plus cos square theta equals 1. That formula, both sides of that formula, I am going to divide by cos square theta. Understand, right? Our second formula, this one, right? Sine squared theta plus cos squared theta is equal to 1. No. Both sides of this equation, I am going to divide by people cos squared theta. I can write dividing both sides by cos squared theta. Dividing both sides by cos squared theta. See what happens? Sine squared theta, we have to divide by cos squared theta. And people, this cos squared theta, we have to divide by cos squared theta. And on the right hand side, 1 should be divided by cos squared theta. It is very obvious thing that this cos squared theta we can cancel down with this. And people here, sine squared theta divided by cos squared theta. This square and this square you can write out of a bracket as a single square like this. Sine theta divided by cos theta, this way perfect square, and this is 1 now after cancelling. We get 1 now. And here this 1 upon cos squared theta I can write as 1 upon cos theta perfect square. 1 upon cos theta perfect square. Why, people? This way when you write, we have to square this sine as well as this cos. Then this is sine square theta divided by cos square theta. This is coming. Then conversely, this one we can write like this. හරි නේද? මෙයා අපිට මෙහෙම ලියන්න පුළුවන්. Here 2 people. When you simplify this, both this 1 and cos theta, we have to raise to the power 2. Then 1 squared is 1, this is coming. Cos theta squared, we write as cos squared theta, no? Here this is coming. That means this term we can write like this. You know this sine theta by cos theta, sine by cos is what people? Tan, no? Tan theta. Therefore, this is tan theta. This is people tan theta. Within bracket tan theta, its perfect square plus 1 is equal to. People, what is within bracket on the right hand side? 1 upon cos theta. 1 upon cos people be defined as sec, no? Then it is sec theta within bracket on the right hand side, right? No? This is people now sec theta perfect square. Yeah. Then tan theta perfect square, we can write as how people? Tan squared theta, not tan theta squared. That we don't say like that. Huh? Tan theta perfect squared is written as tan squared theta. Before we read theta, we have to read square, right? So then we get here people like this. Tan squared theta plus 1 is equal to people sec squared theta, right? So therefore, this is of course written tan squared theta plus 1. By interchanging this order, we write this as 1 plus tan squared theta is equal to sec squared theta. This is number 2. Number 2, right? That is second formula, people. Second formula number 2. Okay, right. Right. The third formula we obtain, dividing this both sides of this by people sine squared theta, dividing both sides of this by sine squared theta. Okay, right. So I can take like this. Sine squared theta plus cos squared theta is equal to 1. Write down like this. Dividing both sides by sine squared theta. Sine squared theta. So what do you get? This left hand side, 2 terms. Both terms you should divide by this sine squared theta. Sine squared theta by sine squared theta. And this is cos squared theta divided by sine squared theta is equal to people 1 upon sine squared theta. You can very clearly notice these 2 you can cancel down. 1 and 1 we get, that is nothing but 1, right? 1 plus this 2 squares I can write as cos theta divided by sine theta perfect squared. And here this one I can write as 1 upon sine theta perfect squared. Here you know this cos theta by sine theta is cot theta. And here 1 upon sine theta is what people? Cosec theta. So then I can write this one 1 plus cos by sine is cot. Cot theta perfect squared means people cot squared theta is equal to 1 upon sine theta is people cosec theta. This is cosec theta. Its perfect square, how to write? Cosec squared theta, right? I of course skipped one step. For this cos theta by sine theta, in the earlier, of course, one, I wrote this one as using another step. On this one, cot theta. I didn't write that one. Cos by sine is cot, perfect square this people cot square theta. I directly wrote that. And this is cosec square theta. Cosec square theta. So this is the people third formula number 3. number 3, third formula, right? Number 3, right? Now we have obtained 3 basic trigonometric formulae, right? 3 basic trigonometric formulae, right? Right, now we can go to proof of some trigonometric identities. That is our first part. Thereafter, we will come back to the theory parts again. This lesson people containing more theories. Very interesting lesson, people. More theories are there. Very interesting lesson. So by working out questions in this lesson, you can of course improve your simplification skills. Right? Yeah. Okay. Now I am going to write people this 3 formulae at the side to use this while working out questions. Right, now I write that here. First one is sine square theta plus cos square theta is equal to 1. It's number 1. Right now. And next one 1 plus tan square theta is equal to 6 square theta, number 2. Next one 1 plus cot square theta is equal to cosec square theta. This is number 3. 1 plus cot square theta is equal to cosec square theta, number 3. Right. Now we'll write people another subheading: trigonometric identities. Trigonometric identities. Trigonometric identities. Metric identities. Good, right now. Okay, people, now let's see what is an identity. ළමයි අපි බලමු මොකක්ද identity එකක් කියන්නේ කියලා. මොකක්ද identity එකක් කියන්නේ බලමු අපි. Right. Now suppose this relation I'm writing something like this, people, here. A squared minus 4. You can write as a squared minus 4. I can write as 2 squared. This one a minus 2, a plus 2. We can write this. Even here also we have used equal sign. Now this left hand side is equal to right hand side. If I write for my convenience of thinking for this a simple x, right, I can write it like this: x minus 2, x plus 2. Right. Here you have seen this one. Here, this one I can write as difference of 2 squares. That difference of 2 squares I can factorize like this. Okay. Then here we have equal sign. This says the left hand side is equal to right hand side. People, now this equality and consider this equality. X plus 2 is equal to 4. Okay. Can you see the difference of this equality and this equality? People, this one, the left hand side we have x plus 2 is equal to 4. You know, when this x takes 2, then only the left hand side will be equal to right hand side. Here, when x takes 2, 2 plus 2 is equal to 4. When x takes 2 only, the left hand side is equal to right hand side. Okay. But people, here, whatever the value you substitute for x in the left and right, the left hand side is right hand side. Right? Left hand side is equal to right hand side. Okay. Now put x equals like 5. What do you get? 5 squared? 25. minus 4. 21 left hand side. Right hand side, 5 minus 2, 3. 5 plus 2, 7. 3 into 7, 21. See here, 21 equals 21. Put like that any value for x in the left and right, both sides are equal. But here, only x2, only when we put x2, this left hand side is equal to right hand side. Therefore, people, this is called as an equation. In an equation, people, for the variable x, there are countable number of values. But people, this is called as an identity. This identity, people, has many infinity number of values for x. That, in other words, whatever the value we substitute for x in the left and right, both sides become equal. Therefore, this is called as an identity. This is called as an equation. Then people can understand what is the difference between the identity and equation. Identity එකක් කියන ළමයි x මොන value එක දැම්මත් left hand side එකයි right hand side එක සමාන වෙනවා. equation එකෙ හිම වෙන්නේ x ට සමහර equations වල එක value එකයි දෙපැත්ත සමාන වෙන්නේ x තියෙන්නේ. For some equations, people, x has two values, only two values. At only two values, the left hand side and right hand side are equal. So therefore, identity is completely different from what equation. Identity means, people, the left hand side expression has been written in another form. But equation is, people, a particular condition. This thing should be equal to this. Then what is the unknown in the left hand side? Something like that. So now in this case, people, by this trigonometric identities also we mean this kind of equality. Okay, all right, trigonometric identities. We'll take first question here, right? And this tutorial, people, I'll put to the group tomorrow morning. And I suppose to post your tutorial this week. I need your mail address, people. But remember, your tutorial you will receive once your payments is received, people. So then this week, of course, I start to post your tutorial, right? So then I need your mail address. Some of the people last week, of course, sent their email address and some mail addresses. So I am preparing nowadays to send you the tutorial. But this time, people, now you know, in our first group, we started month of April. Month of April up to last month, people, I didn't care about what receiving the fees because all people, of course, found faced huge inconveniences because of the lockdown and everything. And due to that, of course, the most of the students they didn't pay, and I didn't force to pay them. And most of the students they didn't join the class because I put all the recordings to the group. Because some students they said that even they can't buy what you call data card or something like that, and financial issues and everything. So because of that, people, I put that all the recordings without considering about the receiving fees, right? But people, nobody can do continuously like that. Everybody has different types of issues. So therefore, if you do your duty, if I do my duty well, people, in your point of view, you must do that your duty also. And recently I decided most of the students, of course, in the group 1 also, there are nearly people, when I put a recording, there are more than 600 or 700 views. Most of the students they have downloaded. But people, you don't believe that number of students they paid. Very sorry situation, right? So therefore, I messaged last week for the students, those who haven't paid for the last months, you won't be allowed to join the class here in after. That kind of message, finally, I had to send. So therefore, people, that also you have to take into your mind. Most of the teachers, they are doing this online classes, people, they, of course, when we speak together, they say their own experience. Most of the teachers, they say, why do you do like that? I am not doing like that. By the second week, if the student do not pay, I'll sack them. That's how they do. But people, we are different from them, little bit different, not much. I considered up to now no longer we can do like that. So therefore, you have to pay your attention on paying the fees by the second week of every month, people, if you're supposed to continue this class. Otherwise, the people, if you have financial issues, please let me know. I can consider that factor also, right? I'm not going to reveal your personal data to any other one. But people, there's particular way of doing something, no? We have to follow that way. Otherwise, by deviating much from the standard way, we can't, of course, do together something, right? So therefore, you have the chances. If you are unable to pay within the second week, then of course let me know. The usual method is that. Okay. Actually, now most of the time now I took, now you know, you are not going to an institute, right? So now actually I am liable to pay the institute. Can be IMS and Kubernetes pin, you know. People, the reason why I am not joining you through the institute, once you join through the institute, people, I have to do through their what devices. So in the sense, their network and their everything. So then they highly consider the receiving the payment. By the second week, if you don't pay people, nobody can join the class. I can't actually do anything there. So that is why I'm doing these classes on behalf of you, for your welfare. But some students, they misuse this opportunity. Okay. So, but I thought that the other way around, at the difficult time, the student should use my effort, and thereafter they will come back to the path and follow the way. But as I thought, that party does not follow that way. So therefore, now I have a little bit change to do this way. Okay, people, right? Okay.
Excuse me, sir.
Right. So therefore, you have to consider about your payments also, right? Yeah. If somebody has a particular financial issue, people, we can just consider we are all flexible people for any occasion, but that flexibility also we have to confine, because everybody finds some difficulties, right? Yeah. But because of the financial issues, don't stop the classes. All right. If you have a particular sort of issue, people, inform me. I can hear you, right? Okay. Now, of course, people, the other thing is some students, of course, asking the free card. I offered the free cards, but finally, the people who obtain the free cards saying very what bad situations. Some of them are white lies. So they take money from their parents and take in free cards from here. Okay, right? So in that situations also I found in my near past, people, that location, of course, what to do as a human being, right? So that opportunity should be given. Really, student suffering from huge difficulties, in the sense, most of the students at the moment find their parents find more difficulties. But some students, of course, they take that chance. Those students, they can pay well, their parents are ready to pay, but those students are cheating to both parties, to their parents and teachers. Okay, don't be like that. I'm not saying that among you some would like that, but there are students like that. Okay, all right, people. And the some students, of course, they say that, so I didn't participate the class. Right, people, every day I take the attendance. Right, once you go to the attendance, I can see the list of the students that they participated. But once I asked about the payments, most of the students, they say, no, sir, I didn't participate. I came to only one class. Right, like that they say, but they join the class and they take the recording. They take the recording, And they, anyhow, people getting the recording and participating in this online class being the same. The same. So most very few teachers, they do what people online classes lively like this. Most of the teachers, they record and put that into the web or their own way of what communicating this. Therefore, watching the recording same as people participating in the class. Yeah, that kind of situation also we of course experience, right? Okay, anyway, people, we'll continue the lesson. Right, so now I am going to first take people the first question this way, right? Prove that this one, cot theta plus tan theta is equal to sec theta cosec theta. See here, this is an identity. What do you mean by that? People, you know, this theta is an angle. We can put for this theta any angle from 0 to up to 360 degrees, no? Yeah. Whatever the angle from that 0 up to 360 we put, people, right? The left hand side and the right hand side become equal. That's what we have to prove. Okay. Yeah. So then we start, people. The usual way of proving this kind of identity is, most of the time we start from the left hand side. Starting from the left hand side and keep simplifying with using the formulae so far we learned. Okay. We try to obtain the right hand side answer available. Starting from the left hand side, we keep simplifying this until we get the right hand side. Then we started from the left hand side and we obtain the right hand side answer. So therefore, thereby we can say left hand side is equal to what? Right hand side. Understood? That is how we usually prove an identity. Right? So therefore, I'm going to start from the left hand side. Left hand side. Okay, left hand side. Left hand side is cot theta plus tan theta. Right. So now you know how to write cot theta. People, I said, when you write cot theta, we have to write the ratio starting with C. It is cos, no? Cos theta divided by sine theta. This is the cot theta. Then what is tan theta? The other way around, no? Sine theta divided by cos theta. Okay. Right. Now, here, this is, people, a fraction. Numerator and denominator it has. This is also a fraction. Then what do you have here? Sum of two fractions. Sum of two fractions. People, you know, in your early grades, you have, of course, simplified this way, simple fractions, adding simple fractions like this. People, do we simplify this how? Do we add this 2 and 3 and 5 and 1 plus 1 as 2? No, 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 we never do like that. There we do what, people? We take least common multiple for this 2 and 3. The least common multiple LCM of this 2 and 3 is, people, 6, no? That's 6. That 6 we can obtain by this way too. 2 and 3 when you multiply, we get 6. Then this 1 should be multiplied by what, people? 3. This one should be multiplied by what, people? 2, no? Then 3 plus 2 coming. Here, remember, when you take the product of this denominators, when you take the product, when you multiply this and this, when you multiply this and this, to take our common denominator, this 6 is called as a common denominator of this 2 and 3, right? When you multiply these two to take our common denominator, then very easily this and this we can rearrange. You have to use cross multiplication this way. This 3 and this 1 we have to multiply. Then what do you get? 3 here. This 2 and this 1 we have to multiply. Here 2. Here also, people. Here also, right? To take the LCM, right? Common denominator, we multiply this sine theta and cos theta, right? Whenever you multiply this and this present denominators, when you multiply your present denominators to get your common denominator, people, this way we have to multiply to find the new numerators. හරිනේ ළමයි නේද? මේ දෙන්නගේ product එක common denominator එකට ගන්න වෙලාවේ අලුත් numerators හොයාගන්න මේ විදිහට multiply කරනවා. multiply ගන්න. Right. So then people here sin theta cos theta product we take as our common denominator. Then this cos theta and this cos theta we multiply. Cos theta into cos theta is people what? Cos square theta. Sin theta into sin theta, sin square theta. Right now? Okay. Now we can furthermore simplify this, people. We can furthermore simplify this. Yeah. People, you know what is this? Cos square theta plus sin square theta. It is this, no? Here. Cos square theta plus sin square theta. It is equal to 1. So therefore, this thing is 1. Right? This thing is 1. 1 upon sin theta cos theta. Okay, this 1 upon sin theta cos theta, right? I can write 1 upon sin theta multiplied by 1 upon cos theta this way. Correct, no, people? You know, when we multiply two fractions, how to multiply, people? Huh? When you multiply two fractions, people, half multiplied by 1/3. How to do this now? That time we multiply like this. 1 into 1 is 1. 2 into 3 is 6. This is 1 upon 6. Like that, when you multiply this fraction and this fraction, we get this, no? 1 into 1 is 1. This is coming. Sin theta into cos theta is sin theta cos theta. This way. So therefore, conversely, this one you can write like this. But people here, what is 1 upon sin? It is cosec. 1 upon cos, what is that, people? Sec. So therefore, this is now cosec theta into sec theta. Cosec theta into sec theta. So now see here, we started from the left hand side here. The left hand side, we kept simplifying this, and finally we obtained this way. We started from the left hand side. What is this, people? The right hand side. So therefore, we can write this cosec theta, sec theta, the product we can interchange, you know, people. You know, 2 multiplied by 3 and 3 multiplied by 2 being equal. Like that, people, this one, if necessary, we can write cosec theta into sec theta as sec theta cosec theta. Understood, right? So therefore, this is sec theta cosec theta. This is the right hand side, no? Right hand side. Right hand side. Okay. So therefore, we started from left hand side. Now we obtain right hand side. So therefore, we can write left hand side LHS is equal to RHS. Now you can see here, people, I have used this 3 lines. 3 lines here. You know, this is what, people? It is the congruent sign, no? Right? When and where, people, we use this congruent sign? මේ congruent sign එකේ මොකද ළමයි කියන්නේ? හැම අතින්ම සමානයි. In all respects, they are equal. Correct, no, people? This and this equality, true, people, for all values of the angle theta. For all values of the angle theta. Understand? That is why sometimes we can use, instead of this single equal sign, this way, congruent sign. Congruent sign means, people, in all respects, they are equal. හැම අතින්ම ඒගොල්ලෝ සමානයි. ඉතින් මේකත් හැම θ value එකකටම දෙපැත්ත සමානයිනේ. ඒ නිසා, people, අපි මේක සමහරවිට congruent sign එකත් equal sign එකට වඩා ලියන්න පුළුවන්. ඒ කියන්නේ congruent sign එකත් අපි ලියනවා equal sign එක වෙනුවට. Okay, right. So then, people, start the proof. Right. Start that proof. Right. Anybody among you need the recording after the class? Please send me a message. Commonly, I am not going to put the recording to the group, right? Okay. If somebody needs the recording, please put a message, right? You know my contact number. So then I'll put that message to your what number, right? Right. First one, okay, people. Right. Now we'll take another identity, right? Another identity. Right. Take this, people. Next one. Prove that this cos A divided by 1 minus tan A plus sin A divided by 1 minus cot A is equal to sin A plus cos A. Sin A plus cos A, right? Yeah, this is the second identity. From the left hand side, starting from the left hand side, try to obtain the right hand side. But people, it is not always a rule to start from the left hand side. If somebody like to start from the right hand side, starting from the right hand side, keep simplifying that, you can take the left hand side answer. That's also another way. Now the third way also we have, people. What is that? We start from the left hand side and keep simplifying to a particular extent, and we take an particular expression, statement, simplifying this. And this also we keep simplify, and we obtain particular extent of simplifying that another expression. That two expressions we have obtained in the left and right, now we show are equal. Then of course, when you go back, this and this become equal. That is the third method. Very rarely we have such questions, but some questions, people, when we work out, we can use that method too. Okay, no? Yeah. So now I'll give a few minutes, people. Just try to take the starting from the left hand side, the right hand side answer. Huh? Right? Yeah. I'll give a few minutes. Okay, people. Right. Now, in this case, people, when I take this answer, my method is different from the early method. People, no one can say this is the exact method that you must use for a given question. A common method nobody can give you. So therefore, I am going to use a particular method. You might think, then how do we know this is the method that must be used to take this answer? People, don't be hurried, right? People, now learning math means, people, really learning means experience, right? Remember the method you use when you work out a question, people. There are limited number of methods. If you learn all the methods by working out questions, people, that day, no need to inquire from somebody else how to do this question, what's the method. You have all the tools with you. Until then, people, very carefully listen to me and understand the methods, right? So now, some occasions, people, to get the answer for some questions, there are 2-3 methods, right? So in this question also, people, to take the answer showing the left hand side is equal to right hand side, there are 2-3 methods, but I am going to use the very easiest one at the moment. Okay, all right. Now I am starting from the left hand side, people. Left hand side we have this, no? Left hand side is this. What is left hand side? Right. Cos A divided by 1 minus tan A plus sin A divided by 1 minus cot A. 1 minus cot A. Right. Well, you know this. When we have a fraction, hmm, for example, suppose we have this 2/3. This is a fraction, right? The numerator and the denominator of this fraction, people we multiply by the same value. Then what happened to this original fraction? Does it change? No, it does not change. It does not change. Also, dividing both the numerator and denominator of a fraction by the same value, there also the fraction does not change. Okay. Now we use that strategy here. Now here, this is a fraction. Numerator is cos A, a denominator is 1 minus tan A. Then both this numerator and this denominator. In this case, denominator has two terms, 1 and tan A. Both this numerator and denominator we multiply by cos A. This one we multiply by cos A, and this one we multiply by cos A. And here, both this numerator and denominator we multiply by sine A. Then you might ask why, how? Because wait till you get the experience. The answers for this why, how, people will give solutions with the time. With the time, when you work out questions only, you get the solutions. Otherwise, people, without doing anything, no solutions coming with the time. Okay, right? Then we will first do, people. Once I finish the question, you will see, this is why we did this way. Until then, patiently do questions. Okay. Then you will get your own method. From there on, the people, little by little, you get the idea. This is the approach. Why he did like this. Okay. That is, people, the experience. First you have to do, and then understand. Right. So then I am going to multiply this by cos A. So this cos A, when I multiply by cos A, people, cos A into cos A, what? It's like x into x, no, x into x squared, like that. Cos A into cos A is, people, cos squared A. Right, divided by, when you multiply this denominator, right, this one as well as this tan A, both you should multiply by cos A. And then when you multiply this 1 by cos A, 1 into cos A is cos A. Right? And this tan A, we have to multiply by cos A. And then that cos A we multiply is, I just now wrote here. Now we must write tan A here. But you know, people, tan A is what? Sine A divided by cos A. Right. Okay. And here, this and this we multiply by sine A. Sine A multiplied by sine A, people, sine squared A. And the denominator, both this and this we have to multiply by sine A. 1 multiplied by sine A, sine A. And now this one we have to multiply by sine A. Sine A times cot A. Cot A you can write as cos A divided by sine A. Cot, you know, cos by sine. Right now? Yes. Now, people, you can see a simple simplification here. This cos A you can cancel down with this cos A. Correct, no? This sine A you can cancel down with this sine A. Now the result, if I write, we can write it like this now. Cos squared A divided by cos A minus sine A, okay, plus sine squared A divided by sine A minus cos A. Sine A minus cos A. right? Okay. Now people, this is what I do. You know this. When you have x minus y, this x minus y, people you can write, take in minus sign out like this, y minus x. See here, when you remove the bracket by multiplying this minus sign, minus y, this is coming, minus minus plus x, this is coming. So therefore remember, an expression like this, x minus y, once I take minus sign out, the signs of these terms, the signs of these terms will be opposite, will be opposite. Using that fact, people, I can take from this sin A minus cos A, I can take minus sign out. Then minus sign come in here, then within bracket, people, what must be written? This cos A should be first with plus sign. The plus sign A should be secondly as minus sign A. Understood? Then we can write that step next, right? This now, people, cos squared A divided by cos A minus sin A plus, this is sin squared A divided by, people, take this minus sign out. Then we can write this as cos A minus sin A. No? Okay. People, now here is plus sign and minus sign. Plus divided by minus. Plus divided by minus. People, plus divided by minus is what really? When we divide two different signs, the answer is minus, no? So therefore, this division I can write as minus now. Cos squared A divided by cos A minus sin A. Plus by minus is minus. Sin squared A divided by cos A minus sin A. We get this right now. Now you can very clearly see, people, here this denominator and this denominator are equal. And here we have a fraction minus another fraction. Here we have difference of two fractions, people. Difference of two fractions. We know when we simplify this subtraction, we must have equal denominators. But at the moment, we don't have equal denominators. If we had equal denominators, people, if it is something like this, 2/3 like this. If the denominators are equal, people, keeping this equal denominator as the common denominator, we can directly subtract 1 from this 2. 2 minus 1 is 1. Here, people, we have that equal denominators. In order to get that equal denominators only, people, I took minus sign out from this and we get like that, the same denominator now we have. Then we can write this one, how, people? This one we can write cos A minus sin A. Now we can write, people, numerator as cos squared A minus sin squared A. හරිද ළමයි? අපිට මෙහෙම ලියන්න පුළුවන් දැන් නේ. දැන් මොකද කරන්න, people? අපි මොකද කරන්න දැන් ළමයි? කොහොමද අපි මේක ලියන්නේ? Here we have, people, here a square, here a square, in between them we have minus sign. Difference of two squares. People, what are the factors? A squared minus b squared, what are the factors, people? Right? A minus b into a plus b. Like that, here you can write factors. What are the factors? You can very easily remember the factors. First, ignore these powers. Then what do you get? Cos A minus sin A. That is first factor. How to the second factor? Change the sign of the first factor. These two opposite. Cos A plus sin A. They are the two factors. Then you can write cos A minus sin A, cos A plus sin A, divided by cos A minus sin A. Now what can you say, people? This one You can cancel down with this. Then we get what? Cos A plus sine A. Cos A plus sine A. Then what is cos A plus sine A? It is this, no? Cos A plus sine A we can write as sine A plus cos A. So then what we have is, people, now I erase this one now. Left hand side only in the left of this congruent sign we have. Now this step I must write down, but I am writing that here. Right now we have cos A plus sine A. Cos A plus sine A only we have. People, cos A plus sine A is the here sine A plus cos A, because when we interchange this order, it is still same, people. Then this is the right hand side of the thing we need to show. So this is the right hand side. Therefore, we prove left hand side is equal to right hand side. Left hand side is equal to, people, right hand side. Understood? That's how we take. Right. Take it, people. Right, people. The next one. At the next one, take this. Prove that. Sine A divided by 1 plus cos A is equal to 1 minus cos A divided by sine. This is what we need to do the next, as the next. Right? Right. Take few minutes, people, and try. Right. Now, people, I am going to start again from the left hand side. It's sine A divided by 1 plus cos A. Okay. Now, the fraction, this, people, I multiply both this numerator and this denominator. We multiply by, people, 1 minus cos A. Here we have 1 plus cos A, no? We take the sign to opposite, then we get 1 minus cos A. Right? Like that, people, when we have an expression of two terms, A plus B, for example, by changing this middle sign to opposite, we get A minus B. This one is called as, people, the conjugate. The conjugate. The conjugate of what? A plus B. Conjugate of A plus B. Then what I do is, people, this numerator and this denominator, both we multiply by the conjugate of this 1 plus cos A. That means conjugate of 1 plus cos A is, people, 1 minus cos A. හරිද ළමයි? මේ වගේ A plus B වගේ statement එකක මේ sign එක මාරු කරලා ගන්න අලුත් term එකට කියනවා මෙයාගේ conjugate එක කියලා. Right? So then we multiply both this numerator and denominator by the conjugate is of 1 plus cos A. So then what do you get there? Sin A times 1 minus cos A divided by 1 plus cos A into 1 minus cos A. Like this. So we should multiply both the numerator and denominator by that. Otherwise, what happens? Otherwise, when you only multiply either numerator or denominator of a fraction, people, the initial fraction will change. That means the initial question given us, we have changed. Now we are working out, people, not the given question, our own question. Then you won't get marks. නේද ළමයි? උඩ විතරක් හරි යට විතරක් හරි multiply කරන්න බෑ. උඩ යට දෙකම multiply කළොත් තමයි අර fraction එක වෙනස් වෙන්නේ නැත්තේ. Right? Okay. Now you can see. People, this 1 plus cos A, 1 minus cos A. What is that? Today, can you remember after obtaining the very first formula, right? Taking this cos square theta to right hand side, we got there 1 minus cos square theta. And that 1 minus cos square theta, can you remember we wrote as 1 minus cos theta into 1 plus cos theta? We wrote. So then here, 1 minus cos A here, 1 plus cos A here. Go to your formula number 1, and it's sine square theta expression. You can see there we obtain something like this, no? 1 minus cos theta, 1 plus cos theta. The same thing here we have with the angle A instead of theta there. We can, if necessary, we can bring this first term, this second, you know, because you know 2 multiplied by 3 is equal to 3 multiplied by 2, no? Using that fact, we can bring this before and this second be this thing. Then you get this thing, no theta. But with the angle A instead of this theta. Then if we can write this one as sine square theta, people, how can we write this one? Since here we have the angle A, it is sine square D, no? Sine square D, right? It is, people, sine square D, no? Right. This is now sine square D. Sine A into 1 minus cos A divided by, this is sine square D. Sine square D. Right, no? Because what is meant by sine square D? Sine square D is sine A multiplied by sine A. Understand? Yeah. So now I am going to show, in this case, the way of simplifying that. Really, people, we have sine A times 1 minus cos A. Here now this sine squared A, no? Sine squared A is nothing but sine A multiplied by sine A, no? No, that's true, no? Then this one sine A term you can cancel down. People, if we need to take the answer without showing this step there, this is not compulsory. How to obtain that? Finally, people, the cancellation of the sine A with one sine A term of the denominator, there will be only one sine A, no? In order to remain only sine A term, only one sine A term, here we can do the simplification this way. How? This sine A term will remove, no, after cancellation from the numerator. And from the denominator, there should be only one sine A term. In order to remain only one sine A term, we'll eliminate this square now, 2. That doesn't say this sine A cancelled with this 2. What I did, finally, removing sine A from the numerator, only one sine A term should be at the denominator. That must be the final result. Getting that result, people, we cancel down the rest. We do like that in order to minimize one step. Understand? In order to minimize one step. Okay. Right. So then, probably with that kind of simplification. So then I cancelled sine A with this power 2. It doesn't say, people, the sine A cancel with this 2. Really, by cancelling, what do we mean? What do you mean, people? We mean that sine squared A, sine A into sine A. One sine A we cancel down with this sine A. Another sine A should remain. Only one sine A term should remain. That remain, people, when we cancel down like that. Understand? Okay. So therefore, what we get? 1 minus cos A divided by sine A. 1 minus cos A divided by sine A. What is this people really? Is the one we need to show, no? It is right hand side. So then we started from the left hand side. Now we came to the right hand side. Therefore, left hand side is equal to right hand side. Left hand side is equal to right hand side. This is how we take that. Okay, no? Right. Come back, people. Right. Right. We'll come next question, people. Count these people. Prove that sine A divided by 1 plus cos A plus 1 plus cos A divided by sine A. This is equal to 2 cosec A. That's what the question. Right. We will try this question. Try this question. I'll give you 2-3 minutes. People try this question. Let's see then. Yeah, people here also. This is a fraction. This is also a fraction. I am going to start from the left hand side, right? Going to start from the left hand side. Okay. This now sine A divided by 1 plus cos A plus 1 plus cos A divided by sine A, right? Now this fraction has the denominator 1 plus cos A. This fraction has the denominator sine A. The denominators are not equal. So then people directly we can't add the numerator. You know that rule when we add two fractions. If the denominators are equal only, we can add the numerator. If not, we should find what? Common denominator. How? By finding the least common multiple of the two denominators. But people, this kind of algebraic expressions when we have, or the terms without having numbers to the denominator, when we have this kind of expressions at the denominators, people, as our common denominator, most of the time we take how? By multiplying this with this, that product we take as the common denominator. And whenever we multiply like that, 1 plus cos A times sine A. This multiplied by this we take as our denominator. Whenever you take this multiplied by this as your common denominator, you know the method of rearranging the numerators. By this sine A, we multiply this. By this 1 plus cos A, we multiply this. Then how to write, people? Sine A multiplied by sine A means what? It's like x into x, no? X into x, x multiplied by x is x squared, no? Like that, sine A into sine A is sine squared A, not sine A squared, not sine A squared. We don't write like that, sine squared A, right? Plus, people, 1 plus cos A multiplied by 1 plus cos A. What is that, people? 1 plus cos A squared. 1 plus cos A squared. Correct, no, people? 1 plus cos A squared. Right? That is very simple thing, right? X multiplied by x is written as x squared. If this x is 1 plus cos A, right? And this x also 1 plus cos A. Then we must write that as what? Here 2, no, x is 1 plus cos A, 1 plus cos A, and this way we can write. Right. And now we have to simplify this. People, this 1 plus cos A perfect squared, this no. This is like, people, if you take this 1 as A, cos A as B, A plus B squared. This one comes as A plus B squared. What is the expansion of A plus B to the power 2? Take the square of A squared, plus sign, 2 times A and B product, right? And plus sign B squared, right? That is the expansion of A plus B squared. First one squared, second one squared, and in the middle what do you get? Multiply this A and B and again by 2, 2AB, right? If you have A minus B squared, people, then the middle sign will be minus. That's only change, right? A squared plus 2AB minus 2AB plus B squared, right? Here when you have minus sign, the middle one will be minus. Okay. Now using that, you can expand this 1 squared plus 2 multiplied by 1 multiplied by cos A plus cos A squared means cos squared A, right? Yeah. Then we have sine squared A plus 1 squared. 1 squared is 1 plus this multiplied by cos A. 1 into cos A is cos A. And furthermore, that should be multiplied by 2 people, because here 2AB, multiplying A and B, again you have to multiply that by 2, 2AB. What do you get there? 1 into cos A is cos A, multiply that by 2, 2 cos A. Plus cos A squared means what, people? Cos squared A, cos squared A, right? And what do we have here? Trigonometry is 1 plus cos A times sine A. This is what we get, no? Right. Yeah. Now, people, I can simplify after this. This sine squared A term and this plus cos squared A term we can take together. Now, for example, right, these things you must very carefully understand, people. Now, suppose we have something like this to simplify. 2 minus 10 plus 20 minus 5, like this. Okay, people, we have to simplify this. Then if I write these terms by changing their places, is it possible? ළමයි මේ expression එකේ මේ terms කම්මාරු කරලා ලියන්න පුළුවන්ද? පුළුවන්. It's possible. But with the condition. What is the condition? When you bring a term from one place to another place, we have to pick its sign also. With the sign, that term you can put at any place you like. Now, the sign of a term is always before that. තේරුණා ළමයි? ඕනෑම term එකක sign එක තියෙන යාට කලින්. දැන් මේ 10 ගේ sign එක මොකද්ද? මෙයා minus. What is the sign of this 2? Plus here we have. What is the sign of this 5? Minus. Now, people, if I need to take this 5 from here to another place, not only 5, its sign also you have to take. Okay. Then I can take this minus 5 at the beginning, and this plus 2 I take here, and this plus 20 I write next, and this minus 10 I write next. Then this expression and this expression will be in the same. It won't change. Understand? Okay. Now, using that, people, if I think here, this cos squared day with its sign I bring close to this sine squared day. Understand? See then what happens? It's now sine squared day plus cos squared day. I bring that pair here. Plus cos squared day. And here we have plus 1. Plus 2 cos A. Divided by people 1 plus cos A into sine. Right. I think up to here you could understand. Now people see here. What is this sine squared day plus cos squared day? It's like this now people. Right? Instead of that A, here we have theta. It is 1. So therefore, this is 1. This is 1. Right? Yeah. And I can write it like this. This is 1 and this plus 1 plus 2 cos A divided by 1 plus cos A into sine. This we have. Now because this 1 plus 1 is what? 2, no? Which is 2. 2 plus 2 cos A divided by 1 plus cos A times sine A. Right. Now, here for this people numerator, this 2 is common. Since that 2 is common, we can take that 2 out from a bracket. Once you take that 2 out as a common factor from a bracket, then we have like this 2 outside. Now within bracket we have something. Yeah, what is the expression we get within bracket? Since we have taken this 2 out, this both terms, this and this, we should divide by the 2 we have taken out. When you divide this 2 by this 2, what we get? 2 by 2 is 1. Then 1 come in first. Then 2 and this cos A, when we divide this by 2, what happens, people? That 2 cos A divided by means this way. Now, this and this we can cancel down. Then we get cos A with the plus sign here. 1 plus cos A coming. When you take this 2 out, within bracket we get 1 plus cos A into 2. And divide by what, people? 1 plus cos A times sine A. This thing you can cancel down with this. Okay, now people, right? That 2 things we can cancel down. Okay, right. Now see what happens. Right. So now we have, after cancelling here, we get 1, no, here also 1, no. 2 into 1 is 2, 1 into sine is sine, no, 2 divided by sine. We have 2 divided by sine. Even this 2 divided by sine, I can write 2 multiplied by 1 divided by sine. This way, no, we can write, no. Why? This 2 means really, people, 2 divided by 1. Then here we have multiplication of 2 fractions. How to multiply 2 fractions? Numerators are multiplied together. Denominators are multiplied together. 2 into 1 is 2. This is coming. 1 into sine A is sine A. This is coming. People, due to any reason, this we can't change. Any expression we can write which is still equal to previous. That is why I explain in always. Right. People, now what is this 1 upon sine A? 1 upon sine A. 1 upon sine theta, today we learned as what, people? Cosec theta. Then in place of that theta we have A. Then what is 1 upon sine A? Cosec A. Right. Then we have what, people? 2 multiplied by cosec K. 2 multiplied by cosec K means, people, this is really 2 cosec K. that is the right hand side. So therefore, this is the right hand side. This is the right hand side. Therefore, the left hand side is equal to right hand side. Left hand side is equal to right hand side. Understood? Right now? Yeah. That's how we take that answer. When people will take another one more. Right. The next one is this. The next one is people this. Write down this. Prove that. Prove that. M squared d plus cos squared d divided by sin a plus sec k. We have to prove this is equal to sec k minus sin a. Right. Right. Prove this, people. No. Let's see then how to take that one. Huh? Right. And I'm going to start people here also from the left hand side. Right. So in this case also, here I'm going to start from the left hand side. Right. Then I start from left hand side. This is what we get. This tan squared a plus squared d divided by sin a plus sec k. Right. Because this tan squared d, I can write here. In the formula number 2, if I bring this 1 to the right hand side, this 1 will be minus 1. No? Then in the left hand side, we have tan squared theta. No? Tan squared theta equals sec squared theta. When I take this 1 to right hand side, minus 1. Then this tan squared a, I am going to write. What, people? Sec squared a minus 1. And this plus sign. Correct now, people? That is by number 2, right? And here we have cos squared d. Now go to number 1 formula. Keeping this cos squared d in the left hand side, once you bring this sin squared theta to right hand side, when this comes to right hand side, this will be minus 1 minus sin squared theta. Is this cos squared theta, right? So therefore, cos squared d I can write 1 minus sin squared d. Okay. Divided by what, people? This is sin a plus sec k. Okay. Now this minus 1 and this plus 1 you can cancel down. Then what do we have here? Sec squared d, this one, minus sin squared d. Divided by what, people? Sin a plus sec k. And now, people, this sec squared a is like a squared. This way, minus sin squared a is like b squared. Then, people, here we have the form a squared minus b squared. But a squared minus b squared mean what, people? Difference of two squares. What are the factors? First factor we can very easily obtain, ignore this 2. We get a minus b. Second factor can be obtained, changing this to opposite, a plus b this way. Then here we can write this as sec k minus sine a and sec k plus sine a. Sec k plus sine a divided by here sine a plus sec a. Right? Yeah. People, now sec k plus sine a, you can cancel down with this sine a plus sec k, because this sine a plus sec k you can write as sec k plus sine a. These two are the same. Then you can cancel down them. Then what do you have? Sec k minus sine a, right? That is, people, the right hand side, no? Then this is the right hand side. Therefore, we can say, therefore, the left hand side is equal to right hand side. Right. That is how we prove the trigonometric identities. Okay, people, then I'll put this tutorial, right, to your group, right? The PDF file I'm going to put. So you can take that PDF file if you have a print at your home, people. Then take a copy until I send you this tutorial. Okay, right. So now, people, I need your addresses. I'll put, right, one link. That means I'm going to schedule your class to start next day. In that, people, through Zoom, you will receive one link. Once you click that link, people, you get a form. In that form, some informations are asking. People fill that information. Among one information, people, your address is there. Correctly put your address there and phone number and your name. Then from that one, I'll take what your all address. That is first thing. And the next thing is, people, in the group, I'll put the account numbers to which you have to pay. When you pay, you will receive a particular slip, no, people. You have to get the photo of that slip and send me that through WhatsApp. There you have to mention your name and Wednesday 2023 class, like that you have to mention. Because, people, there are 4 groups at the moment. One is Monday morning, other one is your one, and other 2 small groups available. That small groups, people, actually some group classes, including only some students, they of course their own group that. Okay, so therefore sometimes your name might be going to those groups, because I am not the one who mark everything here. Now, people, after opening this country, some of my all students, now they are waiting for the university entrance. They are coming to help me. They only do this thing. Some occasions, people, they everything they enter, but at the correct place they are not going to enter. So if you don't put your information correctly, so therefore put that too. Okay, right. So then, people, before next day, the same thing you have to revise again. Okay, and thereafter, getting the tutorial either by PDF or through a mail. People, before next day, people, do at least 2-3 questions and be ready for the next time. Listen. Next day, I suppose to discuss some theories plus some questions, theories and questions. Okay, right. So that's all for the day today, people. Then any question here?